There is a movement going on in America, a growing commitment to quality in our products, services, technology, and most importantly, our people. Continuous quality and productivity improvement is not a passing fad. It has become an economic imperative. And now, more than ever, we must strengthen the vital partnership between academia, industry, and government. How we respond individually and collectively to the challenges ahead will determine our nation's success and survival in the 21st century. Virginia Tech is dedicated to helping you plan, initiate, and sustain continuous improvement in your organization, to challenge and change the fundamental ways you lead, manage, and work, and to assist you in charting a path for excellence in the 1990s and beyond. This teleconference series was developed as a joint effort between the College of Engineering and the College of Business. By integrating the concepts of many disciplines, we believe greater levels of productivity can be achieved through quality leadership and management. As one of the nation's leading research universities, we are dedicated to the discovery of new knowledge and to translating it into practical ways of improving society. Increasing efficiency through effective leadership and management of our nation's manufacturing and service organizations is our goal. We can achieve greater levels of performance by teaching undergraduate and graduate students in our classrooms and by teaching adults through our public service efforts.
As a land-grant university, we're involved in research, teaching, and public service, and we're particularly interested in integrating the resources of the university with the needs of business and industry and private and public organizations throughout the state of Virginia, the nation, and indeed the world as a whole. It is extremely important that we keep current the knowledge base of the individuals that work in your organizations by bringing them in closer touch with the new knowledge generated in the university. We're very much interested in learning of your needs and working with you in creating a set of meaningful programs.
Communications technology makes it possible for Virginia Tech to transmit our knowledge to the world. Through the combined efforts of the Colleges of Engineering and Business, the Division of Continuing Education, and the Office of Distance Learning, you, our audience, can benefit from our efforts to bring change and quality through improved leadership and management. What begins at Virginia Tech reaches far beyond the mountains of Southwest Virginia. The Virginia Tech Perspectives, Quality Leadership and Management series of teleconferences are designed to enhance your understanding of how to improve your organization through increased productivity. Knowledge is both powerful and virtuous, and by learning together, we can solve human problems for the Commonwealth, the nation, and the world.
Good day and welcome to this teleconference on continuous improvement. This is the sixth and final installment of a series of teleconferences on quality leadership and management sponsored by Virginia Tech. For the next 3 hours, we'll be hearing from an expert in the field of continuous improvement. We'll take your phone calls and questions later in the program. Our speaker today is Dr. Philip Huang, Professor of Management Science here at Virginia Tech. A certified fellow of the American Production and Inventory Control Society, Dr. Huang is a former Fulbright Scholar and visiting lecturer at the National Taiwan University. With that brief introduction, let me now turn the teleconference over to Dr. Huang.
Good afternoon. I'm very pleased to have this opportunity to spend the next 3 hours with you, talking about one of the most exciting topics of our time, that is continuous improvement. I remember back in the 1970s and early 1980s, we began to learn about Japanese success and their unique management system. In fact, Japanese management became so popular that there was a little story developed. Many speakers would love to use it. Just in case you missed it, let me share that with you here. 3 businessmen were caught in a revolution somewhere on earth. One of them is a French, the second one is a Japanese, and the third one is an American. They were charged as international spies and sentenced to death. Before they were executed, they were granted the last wish When the French was asked, he said, "I would like to sing my national anthem." And that wish was granted. He proudly sang his Marcellus and then was executed. Then it was the Japanese turn. He said, "I would like to review the principle of Japanese company-wide quality control for all of you one more time." Before his last wish was granted, the American screamed, "I would like to have my last wish before him. Shoot me now. I just cannot take another lesson about Japanese management." Many of us may be sick and tired about hearing the success stories about Japan and their management system. But the question is, have we truly learned from them? Unfortunately, the question may not be entirely positive. Not too long ago, I first read a Sunday editorial on Roanoke Times and then subsequently heard the same story in John Chancellor's commentary on NBC Evening News. They all talk about American auto industry's claim that the demand for higher fuel efficiency is technically impossible. Well, Honda recently just announced that the lean engine they installed on their 1992 Civic model has enhanced its gas mileage to 51 miles per gallon. Apparently, they know something we still don't. In my personal view, I believe one of the major reasons for their success is their attitude of never being satisfied with status quo. In other words, they continuously improve. Today, the focus of my presentation will be on continuous improvement, the very concept that has largely helped Japan to build an economic powerhouse from the ruin of World War II. Following is a list of topics I would like to spend some time on. I will begin by talking about the changing environment and the winning strategy that can help us to compete in this increasingly competitive global market. To demonstrate that such a winning strategy can be formulated, I would like to introduce you a popular technique in Japan. It's called target costing. And the emphasis of target costing is cost reduction through waste elimination. Since quality is the major form of waste, the rest of the presentation will be focused on quality issue. And we will explain some of the principles that can be used to continuously improve, and the methods we can train our workers to do the job well. And lastly, we will conclude this presentation by focusing on the people issue. There's no doubt that people really is the main issue in quality revolution. We live in a world that keeps changing, and many of us have the tendency of resisting change. But change is not that bad. As a matter of fact, without change, we probably still live in caves. So, the human civilization is basically built upon changes. And in the business world, the situation is similar. It becomes a way of life. Without the change, a company cannot meet the changing demand of its customers. So you will lose competitiveness, and it may even fail to exist. So, how to create an environment that cultivates changes will become a very critical issue for management today to address. Now let's take a look at the changing business environment. Technology has been advanced at a very fast rate. Not too long ago, I read an article from Business Week as a special bonus issue on quality. There's a little descriptions about the approach we use to make the 16 megabyte dynamic random access memory chip. The process is similar to printing a map on your fingernail. The map is the Northern American continent, and we will print all the details down to the county line. And it is mind-boggling to learn that the more advanced chip, which is 64 megabyte, will be available in large volume by as early as 1995. Moreover, 24-hour banking, fax machine, and overnight delivery has already become a way of life, and we cannot have them without having problems. And satellite technology has also made a tremendous improvement. And during the Gulf War period, actually, the media has bring your living room to the battlefield. And also, without satellite technology, we will not be able to bring this presentation to your company. On the other hand, since the advance of the technology, we have greatly reduced the distance between people and between organizations. So globalization is a natural result of advanced technology. On the other hand, we also have a lot of changes on the consumer side. Nowadays, the consumers are better educated and they're better informed, with a very detailed and timely information available to consumers about the services and goods they can purchase. The customers now become a lot more choosy. Nowadays, value of the product and services becomes the criterion for consumers to make purchasing decisions. As a result of this changes, that the life cycle of a product has been significantly shortened, and that the providers of the service and the manufacturers will have to constantly understand the changing demand in the market, design and redesign their product so they can meet the demand from the customers, sometimes even exceed their expectations. When I was in Japan in 1987, I spent half a year there. A lot of my Japanese colleagues told me in Japan, they view customers quite differently from Americans. They said, you Americans consider customers as always right. The European believes that the customer is the king. However, we Japanese consider customers as gods. So we have to do everything to please them. In this changing business environment, it is kind of interesting to know that the winning strategy remains the same. In other words, we still need to provide goods and services that are in good quality, in low price, in short lead time, and excellent after-sales service. To demonstrate that, to demonstrate that this winning strategy can be formulated, I have learned one specific technique from my Japanese colleague. And the technique is called target costing system. And it is a system that focuses much more on customers' demand, and so it begins with the marketing study. And in order to implement it, cost reduction through continuous improvement and waste elimination is the main thing. And because of these processes, it promotes the teamwork and cooperation among employees. Now let me explain briefly the procedure they used to implement such a system. And target costing started from a market study. And we need to understand the market competition and to find out the product that will satisfy the demand of our customers. Not only the product needs to be designed in such a way to please the customer, but also it is very critical that we have a reasonable price and that make this product competitive. And when the market price is determined, it is also necessary to estimate the profit. Any organization cannot last long without earning proper profit. And the profit is necessary to sustain the long-term growth of a company. So we need to estimate the adequate profit, and they will set up the target cost as the difference between your market price and your target profit. And after the target cost is computed, it becomes the common goal for all the functionary areas to work together and to achieve that goal collectively. That involves the people from marketing, product design, process design, manufacturing, purchasing, and the shop floor people. So, to reach the goal, the cost reduction apparently is the most effective tool. And the cost reduction does not mean cutting corners. In other words, we cannot sacrifice quality for cost reduction, and that would be a strategic error. So the most sensible approach we can use to cut down the cost is by waste elimination. And what is a waste? Let me define that here for you. Waste can be defined as any resources that include material, machine time, labor, capital, space, and so on. We have to employ them in order to provide the goods and services, but we failed to add value directly to them. And this is a definition of waste. Following this definition, let me challenge you here. Please bring a piece of paper and a pencil with you. Walk down your factory or your workplace. Use this definition to observe your operations and processes. Jot down any waste you can identify from that walk. I bet you $1, by the end of your walk, your paper will not be blank. Using this target costing concept, I have developed the following model, and I call that as a continuous improvement model. And I believe this continuous improvement model will provide us with the basic foundation to build a world-class manufacturing or service providing system. And it starts with a focus on marketing. And we have to look to understand the market competition first. And the Japanese have taught us that market share is very essential for competing successfully. And so gaining market share is very, very critical. In order to have that, price has to be competitive. So the Japanese use the target costing approach and to develop a common goal for everybody to work together. And to reach that goal, cost reduction becomes very essential. And as we explained a minute ago, to reach the cost reduction goal, it is very critical to identify waste and then attack those wastes continuously. So it is my belief that the combination of waste elimination and continuous improvement will be the most powerful tool for us to build a world-class operations. Now, to give you some examples about the ways we can identify and the approach we can use to eliminate those wastes, let me go to the next slides to show you some example. Waste exists almost everywhere in a factory or in a company. If you see the entire process of developing a product and sell them to the market, the first step may be the design. And design change represents a form of waste. And it has been reported that it will cost a lot more when a design change is made toward the end of the process. So the traditional approach of product design, which let the product designer sitting in the corner and try to put his idea on the graph and then toss the blueprint to the process engineer to develop a process plan. And then the process plan developed will be tossed over to the manufacturing shop floor, And the walls separate those functionary areas and creates a lot of barrier in terms of communication. And these barrier actually push the cost high up. So to overcome that, one continuous improvement we can have is to use concurrent engineering concept. Concurrent engineering concept was the main topic of the fourth series of our teleconference here. Dr. Walter Fabrici already talked about that extensively, so I'm not going to talk about that here in great extent. All I want to point it out is this is an approach that will promote early communication among different sectors of the business. That includes marketing, product design, process planning, manufacturing, and purchasing, even the vendors. And through their cooperations in the early stage of the product design, we can avoid very expensive changes in the later stage. Secondly, product design itself can be a form of waste. If you follow the traditional manual approach of designing a product, we do have to prepare a piece of paper, a pencil, drawing tools, and drawing board. And we try to put our idea on a piece of paper. And it is understandable that drawing a three-dimensional chart is a very difficult task, let alone rotate that design on a piece of paper. It's just impossible. Thanks to the current technology, the designer's job now becomes a lot more easier than before. With the new system we call CAD, which stands for Computer-Aided Design, the product designer can sit in front of a computer and put their ideas on the terminal. And computer-aided design offers a lot of advantages. Like the video showing here, it can break down the entire design into basic components and show you the product structure. It can also store the design and then retrieve them later. So we can avoid reinventing the wheel. And the new design, the new CAD system can also allow us to perform testing right on the computer. So it saves a lot of costly testing or destructive testing. Now the more recent solid model can offer the designer a more realistic view, and it can rotate in three-dimensional, provides us with different angles toward this design. And some of the new system can even take the design from a CAD system and automatically generate the process plan, and that is what we call computer-aided manufacturing. And computer-aided manufacturing will turn the design into a process plan and then download to the shop floor and give machine instructions as how to process those parts as designed. So this promotes the linkage between product designer and process engineers and the shop floor people, and it can cut down a lot of product development time and therefore reduce the cost of developing products. So all these give us some examples about the waste and the approach we can use to eliminate those waste. Now let's move down to the process themselves. Manufacturing process themselves, if we don't use the best alternative, it also constitutes a form of waste. For example, nowadays the robot technology has been developed, and we all know once programmed, robot can perform the job with high precision and tirelessly. So if we use the robots to perform the job, we may be able to not only reduce the cost, but also we can improve the quality. So take advantage of the robots is a way to eliminate the waste and then reduce the cost, help us to be more competitive. And most of the manufacturing process involve batch milk production. In a batch milk production, we typically require to take the working process from one machine to the next. And because of this way of processing, we will have to have extensive material handling. And material handling itself does not add any value to your product. Therefore, it is considered as a form of waste. And because of the batch mill production, we also have to spend the time waiting because of the limited capacity of the machine and the transporters. So waiting time is another form of waste we can attack. Because the parts have to spend the time waiting for machine, waiting for the transporters, so the work in process inventory becomes another form of a waste. And for all these wastes, we can attack them by using some of those current technologies. For example, automatic guided vehicles, we call them AGVs. AGV, like this video indicates, is an unmanned transporter, and it is controlled by computer. It can pick up the right parts from the right spots and automatically follow the instructions to deliver the parts to the right place. And because of this system, we can avoid human handling, and the schedule is stored in the computer, so it will get the parts to the right place at the precise time. So that is another way to cut down the waste. Now, in addition to AGVs, there are two developments that can help us greatly reduce material handling, waiting time, and inventory. And they are just-in-time and group technology. Just-in-time was invented at Toyota. Back in the 1980s, it became very popular even in our country here. Just-in-time starts with the belief that inventory is the root of all evils. Traditionally, we consider inventory as a necessary evil. Although it costs us money to carry them, it occupies the floor space, it ties up the capital resources, and it requires double handling. But we need inventory in order to smooth the production, in order to keep our customers satisfied. So that's our traditional view. But back in the 80s, we learned from Japan that inventory may be an evil, period. Why do we say that? Well, the reason we need inventory is because we have operational problems. So inventory is used to cover up those problems. So it does not give us a chance to trace the source of the problem and then remove them permanently. So having a lot of inventory does not help us in the long run. So there's a famous slogan of just-in-time production. We will produce or purchase the necessary product or necessary items only at the necessary time in the necessary quantity. In other words, we believe it is a mistake to overproduce. So the smaller lot production has become a symbol of just-in-time production. With the smaller lot production, we know the waiting time can be shortened. We all have the experience when we purchase the grocery from the supermarket. It is a lot quicker to go through the checkout stand from the express lane when everybody has only a few items to check out. Same thing happens in the manufacturing environment. If the job batch has been reduced, then it can help us to pass through those different production stages a lot quickly. And so the material handling becomes smaller, the waiting time becomes smaller, and the inventory is also smaller. Now, just the group technology. Group technology is another concept that can help us to reach the just-in-time. Now, we know that the batch mill production requires the movement of the parts from one area to the other, and that requires handling. And as the business or product design becomes more complicated, the traveling distance can be excessively long. And the concept about group technology is to classify those products we have to process into a major family according to their production process required. Then the equipment needed to process those family of products can be allocated in a smaller area. Like this video demonstrated, this is a classical example of flexible manufacturing system in Ingersoll Rand. and still in operation right now. And here we group different type of machines in one smaller area, and then the parts can flow through a lot more quickly, and also it helps us to reduce the setup time, since most of the items belong to the same family, requires a similar setup. And also because the distance travel is shortened, and then we can cut down the material handling time and efforts. So the waiting time is smaller and inventory can go down. So all these are examples of identifying the ways and trying to figure out a way to attack them and reduce the costs associated with them. And the last example in this model, although it's not a complete list here, is the quality defect. Quality defect represents another form of waste. And it can be the worst form of the waste. And in general, there are two different ways to identify quality defects. One, through the inspection process. Secondly, we can identify the defects by the complaint from the customers. So let's look at the first part. If we found the defect through the inspection process, usually we have two solutions. Either we have to rework or we have to discard that unit. And rework means we have to put additional resources, and that will cost us money. And if we look at the statistics reported in the industry, some company reported that they probably have to spend as much as 20% of their labor resource simply by producing defects and then correct the defects. And that is a tremendous waste that will not help us to be competitive. So it is important to identify these kind of wastes and eliminate them. Now, discarded units usually contains a lot of resources, such as raw materials, labor, machine time. So if we give them up, and that's a major form of waste. So we need to cut that down too. And the second way to identify defect is by complaining customers. When that happens, we need to recall and fix them, so that will add the warranty cost. And it is also very likely that the excessive amount of quality defects will hurt our product image, and then we will lose the sales, and that is an opportunity cost we have to bear with. Now, all these can be illustrated by the following diagram, which I modified from the famous Dr. Damon's quality reaction chain. I call that quality vicious cycle here. Now, if we start from the top of the chart, when we have excessive quality problem, in other words, we generate a lot of defects, then there are two possible results. One is the customers become unhappier, and the other is we have to rework on them. And if we do have to rework, then it will push the cost up as a result. Now, when we add the cost to your product and we have a lot of unhappy customers, and it is easy to understand that the results will be a losing of our competitiveness. When we lose the competitiveness, and then it is natural to have much smaller market share. When the market share is shrunken, then we cannot expect to earn a higher profit. So when the profit suffers, then it is usually possible to take two different approaches, short-term approach. One is to lay off people, and the other is to hold all the investment projects. When you lay off the people, then you create a job security problem, and we cannot expect the employees to contribute 100% if they don't have the job security. And if we hold investment, then we are giving up the opportunity to use the current technology, more efficient, less costly, equipment. So combining those outdated equipment with workers that are very dissatisfied with their treatment, then it is natural that the quality will be further declined. And then the vicious cycles will repeat itself again. Now, how do we reverse the cycle? Well, total quality management is perhaps the most effective way that can help us to reverse the vicious cycle. Now, as Dr. Damien said, we need to change our management philosophy. And we need to realize that the business environment changed. Back in the 30 or 40 years ago, the business environment is quite different. At that time, American products seemed enjoyed an unlimited demand. So the issue at that time was really how to produce in large volume and how to lower the production cost. But that mass production era is rapidly disappearing. And now we have to compete a lot more on the basis of quality. And the price is no longer the major concern over here. Now, since we have to compete based upon quality, and we need to address the definition of the quality. As many of you probably viewed the video program that broadcasted by public broadcasting system, the title of the program is called Quality or Else. And many people in that program gave us different types of definition. Now, I don't have the time to run through all the different definitions about the quality, but there's one thing we need to understand, which is the meaning of the quality has been expanded drastically. And just conforming the specifications is no longer satisfactory. And we need to understand that the quality is what the consumers say it is, not what the product designers or manufacturers say it is. Now, in order to produce quality product, and we need to change our definition about customers too. Traditionally, we believe customers are those people who buy our products or take our services. But now, we need to expand that. In order to have a true quality improvement, we need to understand our job is not only satisfying the external customer, but also the internal customers. What is internal customers? Well, anybody that will take the job that is processed by us become our internal customers. Okay. So that is expanded definition. Following this definition, we can understand that the total quality management really requires the company-wide participation. And we need all the different functional areas to participate in this great revolution. So as Dr. Damien said before, it is very important to break down the barriers, promote the cooperations among different type of people. And we also need to change our concept. Traditionally, we believe quality can be guaranteed by inspection process, which is no longer true. Let me give you a simple example here. There is a truck trailer company, and they use a fastening device to tighten those major parts. And to ensure the quality of those fastening devices, they had an inspection process developed. They had a sampling plan that would take random samples from the delivered parts. After careful examinations of the parts, they would determine whether the quality is acceptable or not. At one time, the workers found a consistent problem, which is the bolts cannot fit with the nut. And the reason is the threads were crossed. And the problem is so persistent that they decided to go 100% inspection, try to uncover the problem. The surprise we found was as they went to 100% inspection, the problem got worse before it gets better. And that really is a strange result because 100% inspection supposedly can remove the entire problem, but it failed this time. And after close study, they found out the problem. The problem is not the vendor. The vendor did supply quality parts, and the problem was the inspector. The inspector was newly hired and he was not trained properly. We know the fastening device for a major product can be very heavy, and this time it weighs a few pounds. And the inspector followed a wrong procedure. When he finished the quality inspection, record down the results, he simply tossed the bolt down to the beam. And it's because the weight of the bolt and cross the threads becomes unavoidable. So they found this problem and they tried to improve the process, and then the quality problem has been resolved. So this demonstrates that we cannot expect inspection to remove all the problems. The true source of the problem, as indicated on the next slides, are really from two different places. One is the product and service design. And second is the manufacturing process and the service delivery. So unless we can attack the source of the problem, then the problem will be persistent and we cannot resolve them. And we also know that correct problem is costly and sometimes it can be very frustrating. So I would suggest that if possible, we should do it right from the first time and every time. And this is important because it can help us to standardize the process and to avoid expensive rework and corrections. And also, when we implement total quality management, and we should have a long-term perspective, because in the short run, we do need to invest, and that will push the cost up. But if we look at the long-term profit, then we will find it is very helpful to have a total quality management program. And so Kaoru Ishikawa, who was a Japanese quality guru, once said, "Set your eyes on the long-term profit and put quality first." And we also later learned that although at the early stages of implementing total quality management, the cost indeed will go up, but not consistently. In other words, it will go up first, then reaches a plateau. As we improve the quality, we cut down the rework, and then the cost will decline rather than go up. And that is something we call them as a Mount Fuji effect. And we can use Deming's quality improvement chain to further explain this Mount Fuji effect. And as shown in the next slides, next diagram, Deming's quality improvement chain is actually the opposite of the quality picture cycle. So we can just reverse the order, and when the quality is improved, then we found that the customer becomes happier. And also, because of the improvement in quality, we can cut down the waste, we can cut down the rework. And because of that, we can effectively increase our effective production capacity. As a result of increased production capacity and lower amount of rework, we can cut down the cost. And the cost reduction combined with happier customers certainly can increase our sales. So as a result, our market share will be larger and our profit will be higher. And since we have a higher profit, we do have the resources to reinvest and to acquire the modern technologies and take advantage of them. On the other hand, once the company becomes more profitable, then our job becomes more secure, and then the morale of the workers will be higher. So combining the increased investment in high technology and our dedicated workers with high morale, and then we can expect quality to be further improved. So this starts the cycle for the next time around. So indeed, the quality management can help us reduce the cost rather than increase the cost. However, there are strategies we need to follow to implement total quality management. As Kaoru Ishikawa said, TQM starts from education and ends with education. And so we need to emphasize tremendously on the continuous improvement process. And so the next subject we're going to talk about are the principles of improvement. And here we have different views toward improvement between Americans and the Japanese. Americans usually are very creative. So our improvements are usually some breakthroughs, such as Ford's assembly line, such as Taylor's scientific management, and that will bring our productivity to a higher level drastically. And that is our typical approach to improve. But scientific breakthrough or technological breakthrough, they do not happen on a daily basis. Therefore, we can expect a flat productivity for quite some time before we jump to the next level. So the next slides can show you a picture to describe the continuous improvement of the American style. And that improvement can be described by a step function. And the step function goes up at a step, but in between it's quite flat. And that can be used to describe our basic concept or practices of the continuous improvement. But Japan used a different concept. The Japanese believe small and continuous improvement are highly desirable. So as this slide indicated, we have a line rather than a step function here. The Japanese will aggressively acquire new technology from the Western countries, and once they acquire those technologies, they will not sit there and just waiting for another breakthrough. Instead, they will examine the process and try to find a better way to use it or modify it and to have a higher productivity based upon that technology. So the productivity improvement can be described not as a step function, but a line segment that goes upward. So with this kind of improvement, there's no wonder why they can compete so favorably in the international markets. And also, when we try to improve, we need to understand that quality problem should not be blamed on the workers. As Damien and some of the major companies in our country demonstrated, that workers are only responsible for less than 20% of our problems. And because generally workers do have the desire to perform well on their job, and it is the management system that prevented them from being creative, from being participative, from being continuously improve our processes. And how to unlock the employees' creativity is really a critical issue. So the manager's role will be changed as we move along the road of continuous improvement. They no longer was the command giver. They have to play the role of an educator, of a coach, of a facilitator, of even a cheerleader. So with this, we understand that the management needs to change and needs to understand the movement and be able to take advantage of this revolution here. So training, and training, they are so important. We need to understand why continuous improvement, why total quality management is needed. Now, there are a few things maybe quite different from our old practices, and let me share that with you here. Quality improvement has to be based on facts. It cannot be based on intuitions or subjective judgments. And also, it is not good to just work harder. We should not require the workers to work harder. Instead, we should train them, educate them, and help them to work smarter. And also, they need to learn that it is better to do it right than do it fast. So we also need to change our performance measure and not evaluating workers by the volume. We should evaluate them by the contribution they made in terms of producing quality products. And the other thing we should pay attention to is the problem solving. When we solve the problem, we should not use the Band-Aid approach, and we should go to the root and remove them permanently. And let me give you one little example to conclude the first part of the presentation. And this story was told by Kaoru Ishikawa in his famous textbook entitled What is Total Quality Control? Ishikawa described a little case here. And there is a new device we try to attach to a machine. And in order to attach the device to the machine, we need the fastening devices too. So as indicated on the next slide, we have a plate that connects the device to the machine. In the center, the circle represents the new device. And the 4 small circles represents the hole that we can insert the bolt to connect the device to the machine. At one time, they found out one of the bolts snapped. And the solution to that simply is replacing that bolt by a larger size. But it didn't take long for them to find out after the first bolt is replaced, another bolt snapped too. So at that time, it was suggested that all the 4 bolts need to be replaced by a thicker bolt. And as you probably can tell that after some time, the system broke down again. All the 4 bolts are still there, but the plate that connects the bolt to the machine snapped in 2. So the suggestion to improve that is to use a thicker plate. But that is not the approach we should use to solve the problem, because the problem was not the fastening device itself. It is the machine. It is the vibration that caused the problem. So the worker suggests a close examination of the machine operations to find out, which part caused those vibrations. And finally, they found the vibration problem, removed it, and the problem seemed solved. We will be very happy to have a group of workers that will conduct this kind of improvement, but not the Japanese. Because although the problem was removed, but there was another problem remained, which is why didn't the process or didn't the problem detected while they test the design of the fastening devices? So they went one step further. They checked the testing procedure and find out some flaws and changed the procedures, and then the problem is never occurred. I think this is a good example to demonstrate continuous improvement has to go to the root of the problem and remove them permanently. And I'll give this back to Paul and to conclude this first part.
Okay, thank you very much. We're going to have Dr. Huang join us now to sit down and answer a few phone calls. If you've got some questions that you would like to ask him directly, we have a toll-free number that you can call us here in the studios at Virginia Tech. We're going to do a little Q&A for about 10 minutes. We'll take a break. The good doctor will come back and talk to you for a little bit longer. We'll take another break and have another question and answer session at the end of all this. But if you've got some questions right now on what he's been talking about, please feel free to call in and ask him at this moment. I want to start out with a question. You talked a lot about automation and robotics and such. Of course, whenever a worker hears about robots and automation, the worker thinks job loss. Are the two that related? Is there a way of avoiding job loss when you work on automation? How do you incorporate automation?
Well, that's a very good question. I think we didn't have the right perspectives in the past when we consider automation. We typically believe automation is a better way to replace human beings. But I think if we have a long-term perspective, if we focus on the long-term competition, we should not create that fear for the workers. Okay? So it seems to me the right approach to to really push automation is to let the workers understand that their job will not be jeopardized. Continuous improvement should not be made at the expense of the workers' job security. And unfortunately, that's one thing some companies still haven't learned about it. If we don't follow that approach, then I think the total quality management program or continuous improvement process will be doomed.
Okay. Talking about workers too, one of your graphics said training, training, training. When you're talking about continuous improvement, what kind of training are you talking about here? How do you get workers trained?
Okay, if we focus on the workers, we do know that workers, they handle the job on a daily basis. They know the process, they know the problem perhaps better than anybody else. But we do need to let them understand how to identify the problem so that they can attack those problems effectively and successfully. So the kind of training we will need is to help them to understand how to identify problem, how to collect the data, and how to analyze the data, and then formulate a solution to it. Another very important aspect of the training is to let the worker understand that they need to work collectively. So the team approach is very important in solving all those quality problems. So I will suggest that the training program should include a basic training of how to work with the rest of the group. And that is also very important.
Okay, we do have a phone call from Illinois. Go ahead, please.
I was just wanting to ask you, a lot of things that you preach about right off there is exactly what we're doing at John Deere, training. Many of the things. One of the questions always in the back of my mind was, though, in Japan, how is their pay? Is it piecework that they actually work with by getting paid so much per part they make, or how is their pay scale done?
Well, to my understanding, that pay based upon the volume was discouraged in Japan because they believe it's counterproductive. And so to my understanding, the pay scale is based upon the performance of the entire company, and it is not based upon the volume that they're produced. But it can be varied, and 87 when I visited Japan, I visited mostly the large companies such as Canon, such as Mitsubishi, Nissan. So these are the larger companies. I didn't have a chance to see the smaller ones. I don't know whether still there are people paid based upon the volume. But to my understanding, most people would like to avoid that because, as I illustrated in the presentation, overproduction is counterproductive. So using that kind of pay scale, in my opinion, is counterproductive.
You talk about waste elimination throughout your presentation, and of course you think manufacturing, but what about service industries? How do you work to eliminate waste in service?
Well, service industry is also a very important sector of our economy. But if we closely examine the service providers, I believe we can equally find a lot of wastes. And for example, unnecessary paperwork, and that's a form of waste. For example, when you design something, and if you can use better equipment, that can shorten your time. And that is also another way to cut down the waste. So I believe if we learn the basic tool, if we follow the basic principle, service industry is also a very good place that we can implement those tools and to help them become more productive and cut down a lot of waste. For example, healthcare problem. We keep mentioning about the crisis of the healthcare industries, and if we follow the continuous improvement and waste elimination concept and analyze the entire health delivery system, and then we maybe find a lot of ways which we can eliminate that not only help the health delivery system but also help the patients.
Okay, we're going to take a break. You may have more questions. We'll have another question and answer session at the end of this whole teleconference, so jot your questions down now, and we'll have a longer chance to talk later on. We're going to take about a 10-minute break, give Dr. Huang a chance to get a drink of water and rest his voice a little bit. Then he'll come back and talk on continuous improvement methods. So please join us again in 10 minutes. Welcome back to this teleconference on continuous improvement in your workplace from Virginia Tech. We'd like to continue now. Dr. Philip Huang will be talking about continuous improvement methods. Once again, Dr. Huang is a professor of management science here at Virginia Tech. So for the next hour, we'll hear on continuous improvement methods. Go ahead.
Welcome back. I do have an apology to make. We are practicing continuous improvement. So the way we're going to structure the second part of the program, we'll have a little alteration in terms of the sequence of the slides toward the end when we explain the histograms. So I hope you can find that out on your handout. Let's get back to continuous improvement. We do know that the workers are mainly responsible for carrying out those continuous improvement. But just like we cannot send our loved kids to the battlefield without equipping them with the modern facilities, we cannot require our workers to do the continuous improvement job without supplying them with the necessary tools to do it. So the next segment, we're going to focus mainly on the tools and concepts that can help our workers to identify the problem, to formulate the solutions, and then successfully implement continuous improvement. And the first important concept I'm going to talk about is the Deming cycle. And then it will be followed by the 7 tools as indicated on the next slides. The first tool we're going to talk about is the flow charts, and then the cause and effect diagrams, and the check sheets, and histograms and stratification, followed by Pareto charts, scatter diagrams, and control charts. All of these tools are very simple, but nevertheless, they are very effective. So let's start by talking the Deming cycle. We all know Deming is a great guru of quality management. And back in the early 1950s, he visited Japan and lectured extensively. It was his contribution that helped Japan to gain such a tremendous improvement in quality. So Deming cycle actually has a little story here. It was not created by Deming, and it was developed by Walter Shewhart. But it was Deming who introduced this particular concept to Japan. And in my personal belief, although statistical quality controls are very important tools to help improving quality, but the Deming cycle is perhaps the most important contribution of Deming, because it promotes the continuous improvement, and that is the key to their success. So I believe the continuous improvement, which is illustrated by the Deming cycle, are mainly responsible for building the Japanese economy. For that reason, the Japanese do not call them as Shewhart cycle, as it should, but they call it Deming cycle. And what is the Deming cycle? Well, Deming cycle basically involves 4 basic steps. We call them plan, do, check, or act. And now, to my knowledge, that Deming changed the C from check to study. But basically, it's a continuous improvement process. I think the next chart can show you the ideas of the Deming cycle. And Deming believed that the improvement should be continuous, and it should follow some logical steps. So as this chart indicates, we have a big wheel with 4 parts. P stands for plan, D stands for do, C stands for check, A stands for act. And we will continuously roll this wheel upward, and as we roll along the path, and our quality will be continuously improved. So this is the fundamental concept of Deming cycle. And just to illustrate the difficult starting point, we have a slope, but eventually that slope will be flattened as we continuously improve our quality. And about Deming cycle, Let's take a look at the 4 basic steps involved, and I'm just going to illustrate what are the important things that should be achieved by these 4 different stages. Plan. We cannot have effective continuous improvement program unless we identify the right problem to attack. As we illustrated from the previous continuous improvement model, there are all kinds of ways we can observe in any operation. So where do we start? How do we know it's the right problem to attack? And this is the essential problem that should be answered by this particular stage. So in the plan stage, we need to define the problem, collect the data, identify the right problem to solve, and then we have to determine the goal, and then formulate the solutions to that problem. The second stage is a do stage. Now, we do want to take advantage of problem solving and make sure the whole company can receive the benefits. But before we extend the solutions to the entire company, it is a lot more efficient if we can test it in a smaller area and make sure it is working very well. So at the do stage, we need to train the worker and start a little experiment, develop a new procedures, and then implement that new procedures in a smaller scale and test it. So basically, it's an experiment stage. And after that, we go to the stage of check or study. Now, before we can implement the solutions to the entire company, and we have to make sure they are the right solutions to the right problem. So the check or study stage, the main activities involved are the development of effectiveness measures, and then to collect the data, and we check whether the solution basically are effective. So that's the third stage. And the fourth stage is act. As I pointed out, it would be a waste if we solve the problem and then limit that to the particular area, because we have a larger company and there are many places may take advantage of this particular solution, and it may help them to solve their problem. So it is important to extend the functions of the solution by standardizing the procedure. Once the procedure is standardized, we can document it. And with this documented standard procedures, other part of the factory or company can also use the same process to improve their operations. So in this way, we can, we can improve in a larger area and receive larger benefits from those improvement activities. And to conclude the Deming cycle, and there are 2 points I would like to make. When we build the standards, that doesn't mean we stop changing. And that's not true at all. As you recall, the cycle or the wheel will keep moving. We are not stationary. So once the standards are built, we have to go to find another way to improve it. So the standards are basically built to be broken. And the continuous improvement will go continuously forward, and it does not have a finishing line. And that's the basic essence of the Deming cycle. It has been implemented in Japan very effectively, and I think we should learn that lesson too. But just the guiding principle is not sufficient. We need to have some concrete tool to actually solving problems. So the next topic we're going to move into is the 7 tool. Now, the 7 tool are very simple data collection, data analysis tool. It can help us to focusing on the main issue and try to solve them. And let me try to explain why it is called 7 tool. And there's a little connotation about this term 7 tool. 7 tool actually has more than 7 tools. And some people pointed out that there are maybe 9 tools we can use. But why it is called as a 7 tool? Well, this is due to Japanese. In the history of Japan, the samurai will not go to the battlefield unless he is equipped with the 7 basic tools, basic weapons. So 7 tools become a very popular household word in Japan. Now, when people push quality improvement in Japan, they do want to create a name that is easy to remember. So they use the 7 tool, even though we may have 8 or 9 different tools to be included here. So that's the story about the name of the 7 tools. And let's go down to look at the 7 tools themselves. And if you look for sophisticated solutions or techniques, I'm sure you will be disappointed. And all these 7 tools are very, very simple and based upon common sense, based upon simple statistic concept. And any college graduates will be able to handle all of them, and even high school graduates will handle most of them. So they are very, very simple tools, but if we implement them successfully, they can be quite efficient, quite effective. So let's take a look at the first of the 7 tools, which is the flowcharts. And we know that waste exists in the entire manufacturing process or service providing systems. And so in order to identify waste, in order to find the solutions, it is quite important to understand the process first. So flowchart is a graphical approach to help us focusing on the process we are performing, no matter it's manufacturing or service providing. We need to find the system. We need to understand the process first. Okay? And it is a graphical approach, so it can help us to understand it quickly and accurately. However, there's no unique way we can draw the flowchart. Depending on the company, depending on the products, depending on whether it's a manufacturing or service providing system, we will have different flowcharts that can be drawn. And but it is my belief that flowcharts perhaps is one of the most effective tools we can use in the service industry. So let's take a look at some of these necessary things we need to follow in order to draw the flowcharts correctly and efficiently. The first requirement is that the people who is responsible to draw the chart has to have a very extensive knowledge about the process. And without that, it is very difficult for us to draw complete and accurate process flow charts. So that is the requirement number 1. Number 2, we do encourage group participation because different people may miss the important part of the process. But when you have a group of people who perform the job regularly, when they sit down together and draw the flowcharts together, it is very likely they will come out with a very precise and very accurate flowcharts. And that can help us to identify problems and later on formulate solutions. And also, in order to draw the chart correctly, we should provide the people or the group of people with sufficient time. And also, we need to ask a lot of questions, because the more questions we ask, the better we communicate with each other, and therefore the flowcharts can be drawn more accurately and reflects the true situations. And also, this is the tool that helps promoting mutual understanding and the group of participation, so the data should be visible to all. And so drawing the flowchart and posting them on the wall is a way to help people to understand their process. And following are 2 examples. One came from service industry, the other is from manufacturing. I want to use the simple example to show you a basic flowchart, the structure of a basic flowchart. The first one is a driving bank. I'm limiting to the service to a customer coming to the driving bank and want to deposit a check. So if you follow the process, we can use this flowchart to show the sequence of events. First of all, the customer arrives, And then he or she may push the button and then receive the cylindrical container and deposit the check in and send the container to the bank teller. And the teller will perhaps give a greeting and receive the container. And look at the checks and received, try to identify the service needed. And once he or she found out that the service needed is to deposit the check, then the bank teller should credit the customer's account. And after that transaction is processed, he or she needs to place the deposit slip back into the container and return the container back to the consumer, back to the customer, and then enter the deposit on the general ledger. So this picture will show you the entire process that we need to perform in order to serve this particular customer. Now, the advantage of having this flow chart is we can look at it, we can study them, identify any possible way to improve them. And also, it helps the employee to understand, which part of the process they contribute. What is their position? What is their role in the entire service providing system here? The next example is a manufacturing example, and it is a flow chart that can be used to describe how a motorcycle is assembled. Now, the motorcycle has basically three major parts. First is the frame. The second is the engine. The third are the necessary parts or instruments. So this next chart gives you three segments. The first line describes the process of processing those frames. The second related to the engine blocks. The third relates to the parts. So as far as the frame is concerned, we need to go through perhaps three different steps. First, we have to shape them, and then we have to weld the frame together, and thirdly, we have to paint the frame according to the specification. The engine, we need to cast the engine block first, and then we need to assemble the parts that's needed for the engine. And the parts acquisition, we need to purchase them from the vendors, and we probably have to assemble part of them, so that's parts assembly. And some of the parts need additional fabrications, so we may have a parts finishing, and others may need to be painted, so we have parts painting. But all these, after the process are completed, will go to the final assembly line. In the final assembly line, we put the frame, the engine, and the parts together, and then we package them and ship them out. So using this flow chart, it can help the workers to understand the entire manufacturing process involved by producing a unit of motorcycle. And so from these two examples, we can understand that the flow charts do provide the following benefits for the users of the flow charts. It helps us to understand the process, of course, and then it can help us to identify possible improvement. Okay, it can also help employees to understand where they fit in. And with the flow chart, with group participation to develop that flow chart, and we can also promote teamwork and group participation. So these are the benefits of using flow chart. The second tool I'm going to introduce here is again a very basic tool. It has different names. We may call that as a cause and effect diagram. And some people would like to call that as an Ishikawa diagram because this system was first developed by Kaoru Ishikawa back in 1943. And also because the structure of this diagram, it resembles the skeleton of a fish. So people also call this diagram as a fishbone diagram. So we have at least three different names for this particular system here. Now, what is the purpose of this diagram? Well, we do know when a problem occurred, there may be different reasons that caused this particular problem. Now, we have limited time, we have limited resources. It is important for us to concentrate on those important problems. So, fishbone diagram is a way, excuse me, is a system that can help us to relate the cost to our problems. And so it tells us what can be the major causes that create such a problem. Therefore, we can go through a brainstorming session, and the workers can work together and identify the basic problems and we should attack. So it is a very good tool to perform group discussions and brainstorming sessions so that we can narrow the problem causes and then remove them permanently. So it is a very effective tool to provide communications. But it does require something here. Well, the different people, when they view the same problem, they may think about different causes. So during the process of developing the fishbone diagram, it is very likely that we need to have some modifications because we need to consider others' suggestions. And also, we need to know that the fishbone diagram can also be used as a training tool just to help people understand how to attack the problem, how to identify the problem. And it can be used in the daily operation. And the most essential thing is the fishbone diagram can integrate the employees' experiences, intuitions, and facts they collected when they solved the problem. So let me show you the basic structure of a fishbone diagram, and maybe along the process I can help you to understand how this kind of diagram can be drawn and how can we use this diagram to detect the problem and then concentrate our resources in removing those problems. And once again, we have two examples here, one from service industry, the other from the manufacturing. Now, healthcare. For example, one particular hospital, they may found out there are plenty of complaints from the customers or patients. And they complain that the foods the hospital serve are not desirable. They don't like it. So if we consider this is a serious problem, and that particular problem should be recorded as the fish head, and as the block on your chart, the very right-hand side, the big block there says patients don't like the hospital food, and that's the problem we have. So once the problem is identified, then we can have a brainstorming session with the workers, try to identify what are the major causes for having this particular complaint. So the employees may contribute their thoughts, their judgment, and we may come out with 4 basic causes. For example, the patients don't like the food perhaps because the raw materials we use in preparing those food are not fresh enough. It can also be caused because the cooking skill of the chef is questionable, or we don't have a good enough manual to provide variety that will satisfy their needs. Or the last possible reason I listed here is that the food we served is always cold. So these are the 4 major causes that may contribute toward the patient's complaint about food. Then, once we isolate each of the 4 major causes, the next step is to concentrate on one particular major cause and then look into what can be the sub-causes contributing toward that. Let me just give you one example. Why the food is cold? Well, there are 2 possible reasons. One is because the containers we use to carry those food is not good enough, and it let the temperature drop when we deliver to the patients. Secondly, maybe the delivery procedure we use is not efficient enough. For example, we may have a bad scheduling system. When the foods arrive at the patient's bed, the nurse is taking the temperature. So if that happens, we will have to let the food sit in there for a couple of minutes and it becomes cold. So we need to use the fishbone diagram to isolate those potential causes and use a brainstorming approach to list them all, and also we can highlight those important causes that contribute to our problems. The next example is a manufacturing example. It is similar to the example I've illustrated earlier. the screw cannot be tightened just because the threads are crossed. And that's our major problem. So if that's the problem, we enter that description into the fish head, and that's on your right-hand side. And after we identify the problem, a brainstorming session probably can help us to isolate some of the major reasons that we have this kind of problem. For example, the machine we use to produce the screws may have some problem. Or the materials we use to produce the screws may not be right. Or the workers who generate those screws didn't do a good job there. Or the methods we use to either process those screws or deliver those screws are inadequate. So we can isolate the problem into maybe 4 major causes. Then the next step is to concentrating on each major causes, identify the subsequent reasons or subsequent causes. For example, the methods we used probably can be either the way we process those parts or can be the handling of the parts, just like the example I illustrated earlier. When you toss the heavy screws back to the container, the cross may get crossed easily. So we may have to examine the process we used to handle those parts and identify where are the major sources of problem. So you can see from these examples, fishbone diagram is effective and graphical approach to help us isolate some of those important causes that will create certain problems that we are attacking. And so the benefits of the cause and effect diagram can be illustrated here. It helps us to organize and relate the factors to the problems. And also it gives us a good structure to go through a brainstorming session to encourage participation, you get everybody involved, and also the process of drawing the chart can be fun. So it is a method we should consider using. But it is not without any drawbacks. Although they are not serious, but we do have to understand them. Different process, different operations may have different degrees in terms of the complexity. Some of the process may be so complicated that it is very difficult to use the fishbone diagram effectively. That's possible. And also, in the process of developing the fishbone diagram, it requires tremendous dedication and patience from the participants. And it's a lengthy process. We may have to argue with each other before we can finally agree with a particular fishbone diagram. And for the person who facilitates the discussion, facilitates the development of the chart, it can be a very difficult task. The next tool I'm going to talk about is the check sheets. As we said earlier, quality control has to be based on facts. Cannot be based upon subjective judgment or intuitions. So we need to collect the data, because if we collect the data correctly, and we probably can understand the facts. Okay. And check sheet is just a system that can facilitate the data collection process, can help us to get the information or the data that we need. But before an efficient check sheet can be developed, it is essential to ask a sequence of questions. And these questions can really help us to develop the right check sheet to use. Now let me just run down those questions very quickly. We need to understand what kind of data that we really need, and we need to know where can we collect this kind of data, and we also need to know who should be responsible for collecting those data, and how can we collect this data, and what is the right time to collect this data. And once the data is collected, how can we analyze them? And when we find the results of our analysis, how can we communicate the results with other people? So for this reason, the check sheets we developed usually should contain the following basic characteristics. First of all, it should be able to allow us to record the data very easily. And it can be understood by everyone easily. And also, it is designed in such a way it can prevent missing data. And also, it can help us to determine the source of the problem, and it can help us to facilitate quick resolving of those problems. And also, it's flexible enough so we can check several items at once. And lastly, it is important that it is flexible enough to allow us to do stratification, and that's another tool I'm going to talk about later on, because sometimes when the data is grouped together, we lost a lot of important information. Stratification is a tool that can help us to reveal those important missing information from the group data. Again, I'm going to give you two examples, one from the service industry, the other from the manufacturing, to show you how we can use the check sheet to collect the data efficiently. Now, first example is related to the time required to serve a customer in the drive-in bank. Here, I'm sorry that this chart is not exactly the same as the one on your handout because we have difficulties to put the tallies in between. So please just imagine that there's tallies between the time in minutes and the frequency, these two columns. Okay. Now, this is a system we can use to quickly collect the data. We want to find out how long typically a customer would take to get served from a drive-in banks. So we can set up this table and set up this check sheet and quickly record the data. For example, we may set an interval of 3 minutes from 0 to 3, 3 to 6, and so on. So we have a total of 5 different classes. And then we can simply use a timing device to physically observe the customers when they arrive the drive-in bank until it is served, and then we mark that particular customer down in the appropriate class. So if you finish the process, we may have 6 bars drawn in the first class. In other words, that represents 6 customers took 3 minutes or less to be served through the drive-in bank. And 16 of them took somewhere between 3 and 6 minutes, and so on. So using this way, we can quickly collect the data. And the next example is manufacturing related. We are talking about the machine that will fill the bottle with soft drinks. And we want to measure the amount of soft drink we filled and to make sure it is appropriate. So using a check sheet, we can quickly collect that data. We first design the number of classes, like between 11 and the 11.2 ounces, and that's the first class. And the second class includes 11.2 to 11.4, and so on. So what we can do is when a bottle passes us, we can measure the weight. And for example, if it is 11.5 ounce, then we just enter into the third class, and that becomes one observation. So using this way, we can quickly accumulate the data and show us the pattern of the distribution of the soft drink in the bottle. So check sheet is a simple device that can help us to collect the data quickly. The one I have shown you here is not the only one we can use. There are numerous ways we can design a check sheet. The only limitation is our imagination. So there are other examples we can follow and to design a more effective check sheets to help us collect the data more quickly, more accurately. Let's move on to the next tool. The next tool we have is called histograms. And histogram basically is a graphical approach to display the data we just collected from the check sheet. So it follows this guideline here. A picture is worth 1,000 words. And when the data are clustered, it is very difficult to show the pattern. But using the histogram, it's a graphical representation of the data, and we can see the data pattern. We can understand the data pattern a lot more efficiently. So it is a tool that can help us or facilitate us to understand the data pattern. Now, in order to construct the histograms, there are some basic information needed. For example, the first thing we need to decide to decide is the number of classes. Just like the check sheet we explained earlier, we need to know how many classes we have. Secondly, we need to know the range of each class. And thirdly, we need to physically collect the data themselves. And about the number of classes, either too many or too few are not desirable. Because if we have too many classes, and then it is almost very likely that we will have gaps between those bars or lines, and it does not present the pattern very well. On the other hand, if we have too few a number of classes, the problem is a lot of data, a lot of information will be lost when we group them together. So adequate number of classes is a very essential problem we need to answer before we can effectively construct the histograms. Now, fortunately, statisticians have helped us to build some of those guidelines, and that can help us quickly determine how many classes will be adequate for the kind of data we are collecting. So the next slide will show you that particular guideline. And it is the relationship between the number of observations and the number of classes we should use. If we collect the observation which is less than 10, then perhaps we should use 4 classes. However, if we collect 190 observations or more, maybe we should use 9 or even 10 or more classes in order to display the data correctly. If it's somewhere far in between, and this table should give you enough information to determine how many classes we need to use. Once the number of classes is determined, then we need to classify the data into those classes. And let me show you the table here. When you see a table like this, it is very, very difficult to know the pattern. It's just a cluster of numbers. And although we can tell each individual observations, but it does not help us to understand the pattern at all. So for this particular set of data, we can formulate them into the next table by using the check sheet method. So using the check sheet method, we can find out the frequency distributions. For example, there are 3 metal pieces. The hole we drill is measured as 0.997 centimeter. And we have 4 such metal pieces. The hole were about 0.998 and so on. So we can construct this table. And histogram is a graphical representation of this particular table. So let's move to the next chart, and it shows you the histograms of those metal pieces when we measure the size of their holes. And with this histogram, it can help us to understand the pattern much more clear. We know that the center of the distribution is around 10 centimeters, and it follows a bell shape. We have most of the observations closer to 10 centimeters and less observations on both tails. So using histogram, we can tell the basic pattern of the data very quickly. And the next example, again, is coming from the service industry. We may be interested in finding out the typical time required for a customer to spend in a grocery stores. And once again, this is the results of our data collection. It's just a bunch of numbers, and again, we have difficulty to understand the pattern. So we went through the same process, and we can develop a histogram that will show the pattern a lot better. So first, we developed this check sheet, identify the frequencies of each classes, and then the next chart will show you a histogram coming from this particular table. Now the histogram will show you that most of the customer will spend somewhere around 11.5 minutes to go through the grocery store. And so this can reveal the pattern a lot better than the bunch of data. So histogram is a tool that we should train the workers to know how to construct and how to use. And maybe we should understand some of the patterns of the histogram and be able to interpret those different kind of shapes. So the next sequence of slides will show you a different pattern. The ideal pattern of histogram would be a normal distribution like the one shown here. We have a bell shape and centered around the middle part, and we have very little, very small observations located on both ends of this distribution. So anything deviate away from this normal distribution may signal some problems, and we need to pay attention to. So let's move on to the next slides to show some additional patterns. For example, if you draw the histograms and the results is something like this. You have two bunches of bars, but they are separated in the middle. Now, when this is shown, it gives us a clear indication that something is wrong, because this is a result of two different processes in working. So when the workers plot a histogram and see this kind of pattern, they should be alarmed that something's wrong. They should go there and check out and find out what is the problem and how can we remove it. So that's one example. Let's move to the next one. The next one is a pattern we call plateau. Plateau does not show a bell shape. In other words, most of the frequencies are pretty much the same. The way to interpret this particular pattern is we have a process with a large amount of variations. Now, one possible reason is we don't have a standard procedure to follow. So each worker will perform the job different from each other. As a result, we have a distribution like this. So when this distribution showed, or this pattern showed, it is the time for us to examine the process, standardize it, so we can cut the variation down and to have a much better operation. And that's the kind of improvement we can make. And the next pattern we can have is called alternating. Now, alternating is a unique shape. We have one particular class with a frequency higher than the next. And if this happens, the possible reason is we have some measurement errors. In other words, we don't have a consistent measurement here, so it causes kind of variation. So we may have to go back and check our data collection process and find out where are the mistakes. And the next two shows a pattern that's truncated. For example, this is a pattern truncated toward the right-hand side. We have a big frequency toward the end of the distribution. Now, this has probably happened because we didn't provide enough classes toward the end, so all the observations on the high end will be lumped together and form that high bar. And so we need to re-examine what happened and see whether we can correct that. So this is another pattern worth alarming. This is another pattern we call truncated. You can see basically it's a bell shape, but only one half of it. And the left-hand side is empty. Now, this is particularly happen when some of the times we throw out those defects and do not measure them, or we have some of the statistics collected that they will not give us a negative number, so we don't have a chance to have the observation that is lower than the first class. So this can happen, and so I'm just showing you some of the unique histograms, a pattern of histograms that may give us some idea about what can be a problem and how can we examine those processes and find out those problems and then remove them. The benefits of the histograms. And we can see that quality improvement does require data. And using histogram, it can help us to quantify the process, and so we can manage the process by facts. And also, it shows the pattern, and the pattern tells us the variability. And it gives us a means maybe to compare before and after improvement, and that can help us to see the consequences of our improvement process. And also, it can help us to identify the cause of the problem, just like those different patterns, like a plateau, showing the big variation caused by non-standardized procedures. So it gives us the reason for creating such a problem, and then it helps us to remove those problems. But there are pitfalls of using histograms, and first of all, the data has to be current. we are detecting problems based upon the data. So the data has to be current enough. And they have to be accurate, otherwise we will be misled. And also we need to collect enough samples, enough data to get the conclusion that's valid. So sample size is also an important concern. Now histograms does not offer us any solution. It just tells us the problem. It offers the clue as what the potential problems are. But histogram itself never can solve our problem. And this will help us to move to the next related tool we call Pareto charts. Pareto was an economist, and he developed a very famous theory based upon his study. He said for normal countries, for ordinary countries, maybe 80% of the wealth are allocated to 20% of the population. Now in quality improvement, we have a similar applications of the Pareto concept. In other words, maybe 80% of the problem will contribute it by 20% of the reasons or causes. So it is very important that we can separate the vital few from trivial many. The reason is very simple. Company has limited resources, and we have plenty of problems to attack. So the vital few are those we should concentrate in terms of allocating the resources to solve them. So Pareto chart is a tool that can help us to identify those essential, those vital few questions or problems that contribute to our particular problems. But how do we construct the Pareto charts? Following is the procedure that we can follow to construct such a charts. Just like a histograms, first we need to determine the data classifications. How many classes we should have, how many different causes we should concentrate on. And we need to determine the time frame to collect those data and then classify them according to different causes. And then we have to physically collect the data. And the following step is the unique feature of a Pareto chart. After those data are classified according to their causes, it is very important that we rank them. And the highest ranking will be considered first. And that's how we isolate the vital few from the trivial many. And then after the ranking is done, we can plot the results in a chart. And the chart is very similar to histograms. The only difference between Pareto chart and the histogram we draw is by ranking those causes. So we always have a higher bar toward the left-hand side when we compare that to the other causes. Now, the important thing is how do we classify those data? How do we group them into different causes? Well, there are two different ways we can classify them. First is by the results. Second is by the reasons. And the results can be the defect contents and the source of the defects or the timing of those defects. And the reasons that create those problems can include the following. Maybe the raw materials we used, or the operations that's responsible for that particular defect, or the workers who handle in the machine, or the kind of equipment we use to process those defects. So if we classify them according to these different considerations, different reasons, different factors, then we can effectively draw a Pareto chart. So let's move to the Pareto chart, and again I'm going to use some example to show how Pareto chart can be used, not only help us to isolate those important causes for our quality problems, but also it can demonstrate the kind of improvement after we implement some of the systems to correct the problems. So we can have a before and after comparisons. The next example we have is the billing errors. Now, if you concentrate on this particular study to find out the distributions about the potential reasons for having billing errors, we may classify them into different causes. It can be a typing error, it can be a calculation error, or we have entered the figures in the wrong account, or we mail the bill to the wrong address, or there can be any other possible reasons. We call others. So when we collect all those billing errors, we classify them into these 5 different classes. And then what we end up with is a frequency distribution like the one you just saw. We have 81 typing errors, 27 billing errors caused by the calculation, and 22 caused by entering the number to the run account. So if we rank them, put them in that order, we can draw a histogram just like this one you are seeing right now. And the bar indicates the frequency of these kind of errors. So the typo is the major problem in this particular case, followed by the math error, and then the account, then the address, and others. Okay? So this is a clear way, a quick way to identify where are the major problems we have. Now sometimes we prefer to use another chart, not by just counting the physical numbers, but rather by counting the percentage. So this table shows you a percentage of those billing errors. In other words, we found out in this table 54.4% of those billing errors are typos. And then 18% of those are caused by calculation errors. So this distribution is similar to the previous one, but give us different information. And this one is measured in percentage. So the next graph will show you the Pareto chart in terms of the percentage, not the actual count. So you can see from the chart that typo constitute about 54.4%. Notice that there's a line above those bars, and that line represents the cumulative distribution. And so that's the data we had in the early table, but we represent them in this line segments. Now, as I indicated, Pareto chart can also be used to demonstrate the kind of improvement we have made. So the next example we're going to use is to show you what happened if we identify the problem and we train the workers to do a better job. So maybe a month later, when we record the same distributions of the billing errors, we come out with a different thing. Like here, the frequency of the error dropped. So we collect the new data just like before. We rank them. Typing errors still rank number 1, followed by calculation errors. But this time, the distribution is quite different. Let's show the next slides, which is a graph indicating the Pareto chart after the improvement. So after the improvement, you can see we have much lower errors, and therefore all those bars located below the previous diagram. So if we put these two charts together, it gives us a clear comparison of the improvement we have made. So if you post this on a wall, and it certainly can motivate the people to perform more continuous improvement, and they will be perhaps more interested in the continuous improvement activities. And the next tool we're going to talk about is stratification. And as I indicated earlier, when you have a large class, you probably group a lot of data in that large class. In that case, you may miss some important information. So the stratification is a tool that can help us to uncover those hidden information from the group data. And the way to do stratification is to further classify the data we collected in each class by some additional factor, such as the condition, the cost, or the characteristics. And let me just give you perhaps a little bit more concrete example here. Now, the stratification methods, if we use the materials to further classify the data, and we may want to list the different places we get those material and then classify them further. Or we can classify the data according to the vendor we purchase those materials from. Or we can look at the facility and use the age of the equipment to further classify the data, or use the needed tools to help us further classify the data. Furthermore, the workers can be used to further classify the data, like finding different teams, or to use different number of workers or operators. And so all of these can help us to look maybe some of the individuals that will contribute more toward our problem. And I think this process can be further clarified when we go to the examples. But lastly, let's talk about the conditions we can use to do some stratification. We can use climate, temperature, moisture, time, and even different shifts as a basis to do the stratification. In other words, these are the factors we can use to further break down one major class of a histogram into smaller classes. And by looking at the smaller classes, and we can gain additional information about the pattern. So let's move to the example to show how stratification can help us to uncover some hidden problems or hidden information. And the example we are using here is the number of defects we collected. So I would suggest you to look at the first column and the last column first. Okay, the first column and last column combined together, and not just the regular distribution we can collect it, and we say observe 62 days operation. And we found out maybe 2 days we got less than 2 defects. And maybe 5 out of the 62 days we had 2 to 4 defects. Maybe 10 days out of 62 we found defects between 4 and 6. So if you look at the first column and the last column, it gives us a group data. It shows us the distribution of defects among different days. But this data can be further broken down into two parts. For example, we can classify them according to shift 1 and shift 2, and then we have more detailed information in between. For example, 2 days after we have 2 defects created by the first shift, and we have 4 defects created by the second shift, and so on. So let's move to the chart to show the differences in terms of the stratification. Now the group data will give us a plot like this. And we have an overall distribution, although it does show us the pattern, but there are indeed some missing information from here. So the next graph will show the missing information. After we break each class down according to shift 1 and shift 2, this is the results. As you can see from this chart, that apparently the second shift are more responsible for the defects we created than the first shift. So stratification is a way that can help us to detect additional information. Okay. The next example is the billing error once again. And we follow the same approach. We first look at the group data and plot the data on the chart. And then for each other class, we can further break them down according to a specific factor. Now the factor we use to break the major class down further is employee. So we classify them among employee A, B, and C, and to get a different answer here. So if we move to the chart, to the graph, we see this particular pattern here, and that's a group data. The information we can find from this chart is typo and the wrong address are the main cause for billing errors. But it didn't tell us more specific information which we can find by stratification. So let's move to the next chart. When we stratified it according to the 3 employees that are responsible for these billing errors, a different pattern shows up. And you can see from your handout that employee B seems to be the person that we should give more training, because he committed or she committed the largest amount of typos and math error and a significant amount of wrong addresses. So stratification can give us more detailed information, uncover additional problem which is hidden from the group data. So stratification really is a tool that we can use to gain further insight as to formulating the solution of the problems. And the time is running out, and let me move quickly to the remaining 2 methods. And the first one is called scatter diagram. Scatter diagram is a tool that can help us to identify the relationship between a pair of variables. And the reason we need to know that relationship is to find the cause of a problem. If there are certain costs contributed to the problems, then the scatter diagram can indicate that kind of relationship. And scatter diagram uses the graphical display to clearly show the relationship. And the degrees of the relationship can also help us to solve the problem, but we have to use this with caution. So let me give you a couple examples to show this kind of relationship. For example, the typo may be related to the backlog we have. The more backlog we got, we probably will commit more typing errors. Another reason is the accident rate on the shop floor. It may be related to the overtime. If a worker have worked on overtime extensively, then it is likely that they will commit some mindless error and get injured. So that may be a relationship we can establish. The third one is the machine breakdown. It is definitely related to the maintenance frequencies. If we don't maintain our machines frequently, then we will have a more chance to have machine breakdown. So all these relationships can be constructed first, and then we use the scatter diagram. It can clearly indicate this kind of relationship. And here is a plot of the data we collected. For one observation, it contains two values. One is the number of accidents. The other is the overtime the worker has already done. So with the pair of values, we can get one dot on this chart. When we collect several data, we can plot them, and clearly you can see that this data fits a pattern. We can actually draw a line passing through these points, and this line can describe the relationship between overtime and the number of accidents. As the overtime increases, then the number of accidents will go upward. Okay? So following is a procedure we can follow to draw the scatter diagrams. And first, we need to hypothesize the relationship. And then we need to determine how large the sample size should be. And then we start drawing the charts and using x-axis as a display of the causes and y-axis to describe the results. And then we need to find the minimum observation and maximum observation for each axis to determine the basic structure of the diagram. Once that is constructed, we can plot the data on the chart and then provide some additional information, such as who is responsible for drawing the scatter diagram, when we draw it, and what is the thing, what is the time period we collect this data and plot that on the chart. And there are two additional patterns we need to perhaps take a minute to look at them. The relationship can be a negative relationship. So if that happens, the scatter diagram will show a negative slope like this pattern here. And also the relationship can have a different degrees. So for this chart, you see we have a close relationship because the data points are clustered closer to each other. But the next one we're going to show you, the chart are spread around, although generally it follows a negative pattern. But certainly it's a very weak relationship. And the next one actually have this one actually has no relationship at all. So we have to know how to look at those diagrams and give appropriate interpretations of them. And the last technique we're going to move quickly to is control charts. And control charts was developed by Shewhart back in 1924. And the reason we need to have control charts is they can help us to detect problem earlier, before it is out of control. And also, we have to understand that the variation is a natural thing to have. We cannot have a process that will generate exact numbers all the time. It is natural to have some variation. Because of that, it is important to differentiate what we call process shift versus random variations. In other words, random variation is natural. We can only accept them. But if there's a process shift, then that's the time we need to examine the data and then perhaps find a solution to those problems. All right, so it is important to differentiate exceptions from the routines and differentiate the process shift versus random variations. And by this differentiation, we can help the employee to identify when is the right timing to check your process, to adjust your process. Let me also mention very briefly about the ideas and the process we can use to generate those control charts. Control charts usually can be constructed by determining first the sample size, and the main ideas behind the control charts are, as I've described already very quickly, that the variation is a fact of life, and small variation should not cause any overreaction, and also we need to know how small is small. And control charts is a graphical display about those variations so that we can understand when is the right timing to make adjustments. And the next slides will show us the procedures to build a control charts. And first, of course, we need to know the right sample size to collect. And usually, the sample size should be 5 or more. And in order to construct the control charts, we will need about between 25 and 30 sets of random samples. And once the samples are collected, we need to compute the sample means and sample ranges. And sample mean and sample ranges will help us to compute the control limits. And after the control limits are calculated, and we can draw the control limits on a two-dimensional chart. And after the chart is developed, we can plot the sample ranges first on the R chart. And if it is in control, then we should go again, plot the sample means on the X bar chart. And if still in control, then the control charts are completed, and we can start the implementation process. We go through the process, manufacturing process, collect the data, calculate the sample mean, plot them into the chart, and based upon the observations, we can have some different conclusions. All right. But if the data we plot on the charts are not in control, then something is wrong. We need to find the cause. We need to redraw the chart, and we need to go through the process again until all the points can fall into the control limits. And let me quickly go over some of the examples here. Control limits can be calculated using the following equation. Most of the statistic book will include them, and as you can see in this formula, I hate to get into the technicality here, but basically we need the mean, the average of the sample mean and the average of the sample range to calculate the upper control limit and also the lower control limit. And the symbol A2 you see on this slide is a factor which you can look up from the table. And the next slides will show you the equation we can use to construct the R chart for sample ranges. And once again, R bar represents the mean of the sample ranges, and D3 and D4 are factors we can look it up from the table. And the next slides will show you the table for those factors. Thanks to those statisticians, we have some pretty specific guideline here. When sample size is 3, for example, A2 should be 1.023, D3 should be 0, and D4 should be 2.574. If we use this table, we can get the right factors, and then that helps us to construct the control limits. The last thing I want to show you before we end this particular part of the program is some of the pattern that should alarm us, that should inform us that something is wrong and we better check the process and make sure it is all right. And the first is this out of control situation. You can see from this chart there's one specific observation that goes out of the boundary. And that is the case, we need to find out what's wrong. It may be caused by some calculation errors, measurement errors, or it's incomplete or omitted operations. Or it may be caused by some unusual events like a power surge or broken tools. And the next pattern that should give us an early warning is when there are more points located on one side of the chart. And I'm not quite sure you can see that here. When you have runs, that means you have 7 or more consecutive points located on one side of the control charts. Like we connect those by the line segments, you're getting clearer. If this happens, that means we have a major process shift. We may have a new operator, new inspector, new machine, or new setup procedure, and that will change the entire pattern. And that's why we have those situations with more observations on one side of the control chart rather than evenly distributed. And the next pattern that should alarm us is the cyclical pattern. Now, this is happening when you plot the data. It shows a consistent ups and downs. And when this is happening, the data are not scattered around randomly, and it should give us plenty of warning because this may be caused by some of the following possible reasons. It may be caused by the operator rotation or fatigue factor, or we may use different gauges to measure, or there may be some seasonal effects, or simply because we have different shifts and the workers perform the job in different efficiency or accuracy. And the last pattern I want to show you is the trend pattern. Now, the trend pattern, although is undesirable, you can see from this chart, although we don't have an out-of-bounds situation, but the pattern itself gives us enough evidence that something goes wrong and we better check it and correct them. And the trend pattern typically can be attributed to the following factors. Maybe because of gaining experience, the performance of the workers becomes better and better, so that pushes the curve upward. Or the improvement process will help us to gain improving trend. Or the two wells, that causes us to drill a smaller and smaller hole, and then that will give us a downturn trend pattern. Or the equipment becomes too old, so gradually it is losing control. Or the fixture we use is loosening, and therefore we have a consistent pattern that it will go or shift out of the boundary. And what is the process that is under control? Well, we have some signs for the normal operations. And basically, we should have a pattern that is completely random. And a random distributions of the points, and that is still within the control limit, that's a good sign of a normal process. Plus, we should have equal numbers above and then below the line, control line, center line. And if we fail to observe any predictable pattern, and that means we have random observations. And lastly, we should have most of the points clustered around the center line. We also should have a few observations that's closer to the control limits. So anyway, what we're trying to indicate here is if we don't have pattern, we have a random distribution of those observations, and they're all within the control, it's a good sign that we still have a process that's in control, and we should not worry about it. And so this will conclude the second part. I'll get back to Paul.
Okay, thank you, Dr. Huang. We're going to take another 10-minute break here and give you a chance to do a little thinking, write down a few questions that you may want to ask in a few minutes. We'll come back. Dr. Huang will talk about how you and I fit into all this, the human element of continuous improvement. Then we'll take your questions on a toll-free number. So join us again in 10 minutes. Once again, we'll be taking your phone calls in just a few minutes on a toll-free line, so you may want to be thinking about that as Dr. Huang kind of summarizes this last section on the human element of continuous improvement.
I have taught at Virginia Tech for 12 years. My major interest is in production management. One of the things I always like to do is to take my students out of the campus and visit the surrounding manufacturing facilities, and to let them exposed to some of the real-world operations. And in '87, when I went to Japan as a Fulbright scholar, I visited almost 20 companies. And throughout that study, I have noticed the major difference between the American company or factories I took my students to versus those Japanese factories I have conducted my study is really the workers. And my experience is that the Japanese workers are a lot more dedicated, and they concentrate the job with a great interest, and they seem to be enjoying doing their job. So how to motivate the workers so they can get job satisfaction, that is a very, very important issue we should address today. I think the total quality management with a focus on the human beings. And we have a major resource there we didn't take advantage of, and this is the time we learn from that experience. So continuous improvement offers us a new way of management. And as we talk about the role of a manager, it should be a leader, facilitator, coach, cheerleader, but not a command giver. And the true source of the continuous improvement really is the human being, is the workers themselves. So as the next slides we're going to show you, what we need to do is to motivate the workers so they can continuously focus on the design and the process. So they improve it continuously and gradually. And so those improvement ideas can only come from the workers. And management's job here is to unlock the workers' creativity and how to take advantage of that. And let me share with you a very short stories which I heard before. Now, this story is about a company in Japan that uses a precision machine. The company has been very successful, so they have to expand their facilities, and they found a new site to build a new facilities. It's a duplicate of the older one. And one machine operator who is responsible for handling a highly precise machine to perform precision jobs. And after the machine set up and the operation started, she found out a consistent problem. Every time when the machine is calibrated to its right position, and then you gradually lose control. And that problem bothered her a lot. So she requests the help from engineers, from designers, and they study the problem over and over again and still fail to resolve it. Then they called the headquarters and send the technicians from the original plant with the same facility down to help them out. And with a great disappointment, the problem is still persists. And this worker, and she has such a dedication to her job, she just cannot forget about it. How to solve the problem seems a constant thought on her mind. It was one day she got off from the work and went home. She rode a bicycle. So the bicycle has to be stopped by a railroad track where the bullet train was passing. And the bullet train is one of the fast trains available on Earth. It does provide speedy service, but on the other hand, it also creates a great vibration. While the worker waiting for the train to pass, she felt this earth-shaking kind of vibration. And all of a sudden, since she's still thinking about her problem, she thought, could this be the source of my problem? The next morning, she went back to the factory, talked to the engineers, and they tried to measure the vibration. They found out the factory, although it's a distance far away from the track, but still the vibration was so great, it tips off the scale, and so they have the consistent problem. So with the dedication of the worker, keep thinking about the problem, keep finding the solution to it, and even this difficult problem can be resolved. So I think we do need to educate our workers, we do need to empower them, respect their decisions, and respect their works, and that is the only way we can unlock their powers and to help us to move into this new era of total quality management. So let me give you a brief summary of today's presentation. And we started out by considering the continuous improvement as the key for a company to survive and to prosper. We also found out that the major source of continuous improvement really comes from the employee themselves, not the top management. And I think this is a new way of thinking, and we do need to motivate, we do need to guide, to encourage the workers, so we create a desirable working environment that will stimulate the workers' participation. And that's the only way we can effectively improve our productivity and stay in competition. So educate the workers and train them so they have adequate tool to solve problems and to identify problems, and that is a major task of any management. Also, with the continuous improvement, we will have a brighter future, and this is evidenced by a statement that I found from Business Week. In Business Week, there's a statement indicated that Duran gave a lecture to a group of Japanese managers, and he declared that America is to bounce back. And in the 1990s, he said, made in the USA will become a symbol of world-class quality again. So this is really an exciting era, and our future is bright if we know where to put our emphasis on, where to allocate our resources, and how to unlock the power of the employees, and that will certainly help us to regain our leadership in terms of the international competition. So this will conclude my presentation. Thank you very much.
All right, well, you're working your way over here. We invite you to phone in if you do have questions. We do have a toll-free number that you can call. We already do have a call coming in from New River Community College in Dublin, Virginia. Go ahead, please.
Go ahead. Kevin Hawkins from New River Community College. I have a question for Professor Yang in reference to your example of the Ishikawa story with the boat breaking. Just like when you're making improvements within step functions of the design breakthroughs, when you talk about problem solving, does the Japanese view interim fixes as positive or quick fixes, or do things normally wait until the root of the problem is identified?
Well, I think the improvement process is small in scale, gradual, and consistent and continuously. This is perhaps can be explained by the kind of suggestions Japanese company typically received. For example, back in 1990, Toyota reported close to 2 million suggestions from its employees. It is very clear that not too many of those 2 million suggestions are breakthroughs. So they are all minor steps of improvement. But you have to be consistent. As you are consistent, you are persistent to solve the problem, eventually you will trace to the source and remove them permanently. So I believe it's a gradual approach, it's in small steps, but it is continuously moving.
How do you motivate workers to participate in this, though? How do you get them thinking? How do you get them in that mindset of, yeah, I can tinker with this a little bit and get it better?
That's another question I'm very glad to have the opportunity to answer. The reason is back in the 80s, a lot of American companies start using quality control circles but failed miserably. And I think one of the major reasons for those failures can be traced to the way we handle those suggestions submitted by your employees. And when the workers are solving a problem, put their energy, put their attention to identify problem, formulate a solution, they expect some reward, they expect some respect from the management. If we cannot respond to their suggestions in a timely manner, in a respectful manner, and there's no way we can motivate them further to solve the problem for us. So we need to change our attitude, change our evaluation system, so we can create an environment that will induce their further participation, further continuous improvement.
Okay, we do have another phone call from, is it Escanaba, Michigan?
Yes, sir. Good afternoon. This question is from Bay College, Escanaba, Michigan. Earlier in your presentation, we understand you to say mass production is disappearing. To be competitive, don't we need to mass produce high quality, unique products? Your thoughts on that, please. Thank you.
Thank you.
Well, it seems to me the mass production era is disappearing simply because now the consumers demands more. And if you study consumers, they have different tastes, they like different designs, they like different options. So it is almost impossible, say, to sell a Model T to all the customers who want to buy a car. So the variety required by the customer pushes the life cycle of the product become shorter and shorter. So I believe even though you can produce high quality products, that doesn't guarantee you can sell well. You just need to understand the demand from the customers. Let me give you one example. Cadillac, the winner of the Baldrige Award, gave us a very interesting lesson there. And when there was an energy crisis, their design team changed the physical outlook of the car. And the end result is a design that's functioned very well, in good quality, performed very well, but the shape of the car resembles vehicles like a Buick. And that was a big failure, because when people buy Cadillac, they expect a quality that is different from what the Buick can provide. So even you can mass produce a quality product, that doesn't mean you can sell very well.
Okay, our next phone call is from Prince William County in Maryland. Go ahead, please.
I'm Pat Pearson from Prince George's Community College in Largo, Maryland. And I would like to know if in Japanese companies, employees are promoted from within to a higher rank, or do they hire from outside the company?
Well, as you know, Japanese employ a system they probably call a lifetime employment system. So when the employees enter the company, they probably will stay there for the rest of their work life. Similarly, the company will not lay off the workers simply because the economic conditions is getting worse. So with that kind of system, I think most of the managers are promoted from the entrant young employees, work their way up, not hired from outside. To my knowledge, that system really helped a great deal, because if you want to pursue a participative type of management, you need to build the trust. You need to build the communications among those workers. So that kind of a stable employment system does promote a mutual understanding, the ability to work together to solve the problem together. So I heard a story that if you and I start working for a company in Japan, for the first 10 years, we have the same rank, the same salaries, no change at all, disregard our performance. After 10 years, that's the dividing point. If I perform much worse than you, you probably become a higher manager, and I stay in my old jobs. So I think they have a different system there, but the idea is to provide job stability so people can work together.
Okay, we have another phone call from Wisconsin. Go ahead, please. Go ahead. Well, we had a call from Wisconsin. While we're waiting for another phone call, you're offering us all these tools, and I found them pretty simple to understand, even free, which makes me wonder, are they a little too simple? Are we reading too much into these? Do we need to think a little bit more about what's going into these tools?
Well, I think we, in the past, went through a stage we call scientific management. Scientific management was correct at its time. When we had a massive demand, the problem we had was how to produce in large volume. In the early times, when there were a lot of immigrants, communication can be a problem. If you simplify the process, use scientific methods, use those tools to help them, then definitely we can improve the efficiency and productivities. But now we know the environment changes, and increasingly we have to satisfy the demands, diverse need. Then what we need to develop is a simple system that can effectively help us to identify the problem and resolve them quickly. So I think Japanese are very good at learning simple tools, but use them very effectively. And so it is my belief that disregard the simplicity of these 7 tools, but if we can really train the workers, understand how to use them and to apply them effectively, and you will find out that they can be very, very powerful.
Okay. We do have a phone call now from Schenectady, New York. Go ahead, please.
This is Len Kaufman from Schenectady. I wonder how much time you think should be devoted to training.
Okay. That's a good question here. How much time should we devote to training? As Ishikawa says, we should start with training and end with training, so it's a continuous effort because we have to continuously refresh their knowledge about things. And although Paul and I discussed about the simplicity of the tool, but that doesn't prohibit us to learn more sophisticated methods such as Takuchi method or quality function deployment. So there are other tools we can apply equally effective. So there are different stages we can train ourselves, educate ourselves, improve the tools we can use, and then solve more sophisticated problems. So to me, the training is a job without an end. We just continuously have to do that.
Our next call is from Winchester, Virginia. Go ahead, please.
Earlier you spoke about a just-in-time system. With a customer being God and short lead times, isn't it for someone in the supply line to be a just-in-case supplier?
Well, that's an interesting question here. It is my personal view. I have become very interested in just-in-time since the beginning of the 80s. And it is my disappointment to find out some of the companies didn't apply just-in-time in the right sequence. When Toyota developed just-in-time, they didn't push down to the suppliers immediately. It took them decades before they understand the system well, they implement the system well, and then they start train the suppliers to use the same system well. And that is the time they will filter down to the suppliers and ask them to use just-in-time system or deliver the parts in just-in-time. And another thing I would like to point out is just-in-time should be viewed as a system that can help both the suppliers and the users of the product, because we cannot just demand the suppliers to ship parts or materials in smaller quantity and more frequently. We also need to supply them with production schedule, help them to understand the demand better, plan their activities better, and also we have to give them some security so we can have a concentrated purchase, so they have a large volume to plan their production. So it's a mutually helpful thing, not a threat to one another. I hope this concept can be accepted by most of our industries here.
Okay, we have another phone call from Virginia. Go ahead, please.
Dr. Huang, in the case of Pareto charts, would we always rank the causes in order of frequency, or would it ever be appropriate to rank according to some other measure of severity?
Well, the purpose of the Pareto chart is to identify the vital few causes to the problems. So when Pareto developed the chart, that is the way to structure it, and put the cause with the highest frequency on the left-hand side and gradually reduce it. And the reason we're doing that is by viewing the first 2-3 bars, we know where the major problems are, and then we can concentrate on efforts to find a solution to those problems.
We do have another call, Wisconsin. Go ahead, please.
Yes, hi. This is Fox Valley Technical College in Appleton, Wisconsin. And we have a question related to your continuous improvement model on page 3 of your handout. There were several acronyms that you related to, computer-assisted design, just-in-time, but there were a couple of terms that you didn't cover, one being the TPM, the other the 8MED, and also GT. Could you relate back to those, please?
Well, and apologies in order here. I did skip those terms. I think I owe you an explanation here. Let me just briefly define these terms for you. SMED stands for Single Minute Exchange of Die. That is a system with a goal try to reduce all the setup times down to 10 minutes or less. Because in batch mode production, setup time is needed, but the setup activity itself does not add any value. So for that purpose, we need to reduce the setup time. And also, it has a close link to the just-in-time production. Without reduced setup time, it is very wasteful to use smaller lot production, and that's proved by the classical EOQ theory. So it is really necessary to reduce the setup time. SMED is a program to push that direction. And TPM stands for Total Productive Maintenance. Again, this is a Japanese system we imported. It believes that 80% of the maintenance job can be done by the machine operators themselves. We don't need a special mechanics to do the maintenance job for everything. Jobs like lubricating the machine, rearrange the tool, even sweep the shop floor can be done by the operators. So they can create a nice, clean environment to prevent those machine breakdowns. So that's one thing I didn't cover here. CWQC, I believe I touched very briefly. It's a company-wide quality control. It's what the Japanese called the system, and we call them TQM. So it is the similar concept.
Okay, we've got just about a minute left. I want to ask you real briefly, smaller companies, how much do they have to worry about getting computers and computer software to deal with all this? Is this something that's a necessity these days?
Well, if you look at those tools, and they are all very straightforward and simple, and it does not really require a sophisticated or expensive computer facilities to do it. But on the other hand, if we have a better way to facilitate a discussion, for example, using the fishbone diagram, instead of using hand to draw it, if there's a computer program available and we can just directly use them, that certainly is a waste elimination. I'm currently working with a professor at Purdue University to develop such a program so that we can facilitate those continuous improvement activities. Hopefully by next spring we will have a product available.
All right, I'm sure you've got other questions out there. If you do, write them down. You could send them to Dr. Huang in care of the Department of Management Science here at Virginia Tech. I'd like to remind you all to fill out the evaluation forms. We want to know what you think about all this. Thank you all for joining us this day, and have a good day.